Good morning, physics class. We have our next topic of 2D waves, looking at again how water waves, sound waves, light interacts not just along a string or like in a pulse, but again out in its kind of natural world. So how does my sound, like my voice, interact with this room? If I had a big open space of water, if I started moving and creating waves, how would those interact? How do they interact with barriers or obstacles or through little openings? That's kind of going to be what we're talking about this week. Is how do waves, whether it's water or sound or light, how do they interact again with the actual space around us, not just like on a string or in a straight actual little path. So first topic I'm going to go over is like reflection. So reflection of actual waves, and this should be not too hard conceptually to understand, in the sense of you've heard the word reflection before. When you look in a mirror, you see reflection, and that's exactly what it is. When light, which is exactly what you see in the mirror, it's just the light of your body, like when light hits you and then bounces off the mirror, what do you see? Again, if I were to stand in front of a wall, and what does the sound do in front of the barrier, as well as kind of like if water were to hit a barrier, what happens? So we're going to talk about reflection, and I want you to kind of make an example, or think of an example where if you're looking at a mirror and you're looking at it at an angle, what do you see? You see kind of that other angle, and that's exactly what we're going to be kind of figuring out and working on through this. I know it's not up there right now, don't worry, is kind of seeing that other angle. So anytime a wave comes in at an angle, sound or water, anything, anytime it comes in at an angle, let's say it's going to hit this barrier, anytime it comes in at an angle, it's going to bounce off kind of similarly the other way. And that's what I'm going to teach you how to do with a paper and pen, that kind of stuff, is finding that exact angle and recreating that wave on the other side. So let's go through kind of this. I'm going to you'll be able to see me again for a second. Oh, there we go. All right, I'm double. That's just weird. There we go. All right, so this is the first thing that I would try for reflection. It says the Law of Reflection Worksheet Supplement. And the nice thing is the first page literally goes through step-by-step process of how to actually make a reflection question, how to actually do it, okay? I'm not going to go through each step right here, but I will go through each step on an actual question. So here we go. All right, so let's zoom into one of these. Let's do this one right here, okay? So let's actually find this reflection. This is the direction of a wave, okay? This is not a wave itself. If I were to draw the wave, it would look something like this, okay? Where these are all crest. So we have crest, in the middle trough, crest, trough, crest, trough. So you can kind of imagine there be waves coming in at this direction. So this is just what we call the ray. So the waves are coming in at this direction. This is just the ray. And then basically the direction that the waves are coming in. Okay? So I always get the question here, Mr. Westwood, that does not look like a wave. No, it is not a wave. But it is the direction that it's actually moving. Alright? So now how do we actually figure out how is it going to bounce off? We can kind of guess it's going to bounce off somewhere in this direction. But to get an exact idea, let's do this. So you need your protractor. Okay, it looks different than mine. Again, if you need it, come see me. I have a bunch. You need a ruler as well. So this first angle, this line, is called our incident ray. Incident ray. It is basically, I'm going to get rid of this for a second. It is basically the actual, like the direction that it's coming in at, okay? We need to make what's called a normal line. Basically, a normal line is, this is the barrier that it's hitting. I want to know what 90 degrees is from whatever it's hitting. Because if this were to change angles, it would change how this reflects off it. So first, I'm going to find what's called a normal line. So you take a protractor, put it on this, right where the actual ray hits, and I'm going to make a dot at 90 degrees. There's my dot, and then I'm going to make a dotted line. Use that dot, line up back again at the middle, and I'm going to make a dotted line. So this is called the normal line. And again, it is 90 degrees with this bottom, with the barrier that it's actually hitting. Okay? And this is going to allow us to actually find the angle this thing came in at. So this is the incident angle. Okay? I'm going to put a big I. This is the incident angle. Okay? So let's actually figure out what that is. How you do that? Put your protractor on the actual normal line. Okay? Line up the middle with where it meets, and then just like read your actual protractor. So I'm at like 43 degrees, 44 degrees, something like that. I'll put 44. Again, I'm not going to be too picky with the actual angles. If you say it's 41 or 47, 48, that's fine. If you say it's 60, well, that's quite a bit off. But I mean, as long as you're kind of within 3 or 4 degrees, I'll be fine here. All right? So there's 44 degrees. Now, reflection means that it comes off at exactly the same angle. So I need 44 degrees on the other side of this line. Okay? So I'm again going to put my protractor. I have it like this. I'm just going to flip it over. Make sure the middle meets again down here. And I'm going to put a dot at 44. Here's my dot at 44. And now I'm going to create my new reflected ray. Okay? My new reflected ray. All right, and so this is 44 degrees, and this is my reflected angle, and this is my reflected ray. Okay? And so you can kind of see that these are basically exactly the same. If this actual wave were to hit, again, the waves would come off in this direction now. So they came in at this, and now they come off in that direction. Okay? So that's how to do one question very, very step by step. I'm going to do one more example video showing a couple from the bottom of this page where it's an uneven surface and how that uneven surface can kind of change how the reflected rays come off. But there's the step-by-step by first how to do one reflection. All right? Thanks, class. Like I said, I'll do the next examples in the next little video. All right, I'm just going to go back. All right, thanks, class.